On Minokowa, which is very, very new. We've only started working in our open source repository last week, so it's been 1 week. It's been a great experience. Take a look. I want to talk a little bit about what it is, though. So there was a research paper called Kachina about a smart contract programming model, and it was research. So in order to actually realize the Kachina protocol, we had to do a lot of work to design real practical tools, and so we built a programming language that realizes the Kachina programming model. So FabricX talked about a new programming model. We have an interesting smart contract programming model. On the blockchain, there is no code for your contract. The only thing that is manifested on the blockchain is a verifier key for a zero-knowledge proof. The contract is run off-chain with access to public and private state. And so it can evolve the public and private state. And then a zero-knowledge proof is constructed that you properly evolve the state. And the ZK snark, the proof, is sent to the blockchain, which verifies that proof. And along with the transaction that sends the ZK proof is the code that you run on-chain, which is not your entire smart contract. You can think of it as a kind of a slice through the smart contract that is only the public state updates that it needs to do. So the only thing that the blockchain runs is the public state updates. It first verifies the proof. If the proof is verified, then it can run the public state update. So in order to actually realize this, we built a programming language we called Compact. We've built a compiler for Compact. When we talk about barriers to entry in open source projects, I think compiler projects have one of the largest barriers to entry. It's very, very difficult to contribute to a compiler. There's a lot of moving pieces and there's a lot of specialized knowledge. However, there's a lot of other ancillary things that sit around Compact that are much more approachable. So one is that as a programming project, it needs to have, in a sense, a SDK or software development kit that provides a lot of tooling that goes along with Compact. And we've built some tooling ourselves, like there's an updater that updates the toolchain. But you can imagine a lot more tooling that you'd want. You'd want profilers, and you'd want linters, and you'd want a formatter, and you'd want fix-up tools. So we've built a driver for the tools that is implemented in Rust, but it can invoke anything. So you could write a subcommand for the tools that was a Python script, for instance. And so that's one place that people can contribute. Another place that people like to contribute to open source projects to language projects is language design. And I would say that the barrier to entry for language design is even higher than the barrier to entry for compiler contributions. But people don't perceive it that way. They think it's easy to do language design because they can copy something that they've seen in some other language and is ready to go. So we want to make sure that we steer people towards high quality language design contributions. Is anybody familiar with the PEP process that Python uses for Python enhancement proposals? Okay. So it's a defined process for how you can propose design an extension to the language and motivate it well and specify it in enough detail that it could actually be implemented. And then there's a whole process involving editors and a steering council that votes to accept the project and what it means for a project to be accepted. So we've designed a process similar to that that we will use for language design in the open. Okay. That's it? Cool. Did I fit in 5 minutes?